Hello friends, this is the fourth video lecture on disinfection chapter. In the last video, we have discussed about the chlorination, and let's now see what should be the dosage of chlorine which is used for disinfection of water. Now here, the amount of chlorine which you are going to add in the water is not a fixed dosage. It depends upon the contamination of the water. If the contamination is more amount of chlorine is required to be added, and if the contamination is less amount of chlorine is to be added. Now, what kind of contamination the chlorine is going to take care of? One is, as you all know, chlorine is a strong chemical oxidizing agent. So, if any organic matter is present in the water, the chlorine is going to oxidize it. Second is the most important thing. If any pathogenic organisms or disease-causing organisms are present in the water, the chlorine is going to kill those organisms. So, in doing these two work, the chlorine is actually utilized by the water. So, the amount of chlorine whatever you are adding, it is going to be used up by the water for these two, and the chlorine content in the water goes on reducing. Whatever amount of chlorine you are adding, that is gradually going on decreasing because it is used by the water. Now, how much amount of chlorine is used by the water, that is called as the chlorine demand of the water. Now, you have to conduct a small experiment in the laboratory to find out the chlorine demand of the water and then decide the dosage of the chlorine to be added in the water. So, it is actually an experiment which you have to conduct. Now, there is one more term called here as residual chlorine. Now, what do you mean by the residual chlorine? Now, you are adding the chlorine dosage, that is what we call as the applied chlorine. Applied chlorine, that is the amount of chlorine dose which you are adding. And then you have to leave for a time of about 10 minutes. You have to give a time of 10 minutes for the chlorine to react. That is, in that 10 minutes period, the organic matter gets oxidized and the pathogenic organisms, they get killed. So, at least about 10 minutes time is required, which is called as the contact time. Now, after 10 minutes of contact, we have to once again test how much is the amount of chlorine which is remaining in the water after this 10 minutes of contact. Now, if some chlorine is left in the water after the 10 minutes contact time, then whatever is left, that is called as the residual chlorine. This is the residual chlorine. So, one thing is applied chlorine, that is the amount of chlorine which you are adding in the water. Wait for 10 minutes, and if some amount of chlorine is still left after 10 minutes, that whatever is left is called as the residual chlorine. Now, using these two values, you have to calculate the chlorine dosage, right? Now, there is a rule, that is the standard given, that the amount of chlorine which you are adding in the water should be such that it should satisfy the chlorine demand, and after 10 minutes of contact time, a residual chlorine value of about 0.2 mg per liter should be left in the water. That means 0.2 mg per liter extra chlorine you have to add than what is required by the water. So, it should first satisfy the chlorine demand, and then some extra chlorine of about 0.2 mg per liter as a residual should be left in the water. That should be the dosage of chlorine, right? Now, why this 0.2 mg per liter of residual chlorine is selected, and what is the importance of this residual chlorine? Now, when the water is flowing in the distribution system, there is a possibility that because of some leakages or damage in the pipes, recontamination of water can take place. In case if the water gets recontaminated again, then this residual chlorine, whatever is left in the water, that residual chlorine is going to continue the disinfecting action. So, residual chlorine is for taking care of future recontamination of the water and continuing the disinfection action. So, therefore, compulsory some amount of residual chlorine should be left in the water. right? That is one. Second is the presence of residual chlorine gives us a guarantee that the chlorine demand of the water is satisfied and something extra is left. So whether the chlorine demand of the water is satisfied or not, that is indicated only if residual chlorine is left in the water. Otherwise, if you find that the residual chlorine value is 0, then you are not sure whether the chlorine demand is satisfied, whether the water is still demanding any chlorine, you will not come to know. So compulsory, some amount of residual chlorine should be left after the chlorine demand is satisfied. And how much is to be left? That is 0.2 mg per liter. This is going to take care of the future recontamination of the water if it takes place. Right? If water gets contaminated again, then this residual chlorine will continue the disinfecting action and it will take care of the future recontamination. And second is, why not more than 0.2 mg per liter? Right? Now there is a reason here. Large chlorine residue, if allowed, will cause a bad taste and a bitter taste and medicine like smell in the water. And because chlorine is a chemical externally, which is an artificial thing which you are adding in the water, it is a chemical. So excess amount of any chemical in the water is not good for human health, because you are consuming that chlorinated water every day for the entire life. So you have to just add minimum whatever is required. Unnecessary, we should not add more amount of chemical. Plus unnecessary increasing the chemical will also increase the cost of the chemical. Right? So neither it should be less than 0.2 nor it should be more than 0.2. So residual chlorine value should be about 0.2 mg per liter. Right? Now you can just see here there is a formula here. Chlorine demand. How much is the chlorine demand of the water? So when you are conducting that experiment, you will know how much is the applied chlorine, that is the amount of chlorine which you are adding, and after 10 minutes you find out how much is the residual chlorine left. Now suppose I am adding say for example 0.5 mg per liter of applied chlorine, and then after 10 minutes I find that the residual chlorine value is around 0.2. Right? Then how much amount of chlorine is used up by the water, that is called as the chlorine demand. So 0.5 minus 0.2, so chlorine demand is 0.3 mg per liter. Right? That is the chlorine demand of the water. So this is how we are going to determine the dosage. So one thing is, depending upon the impurities present in the water, depending upon the contamination of the water, chlorine demand can be more or less. Usually whenever the rainy season is there, when the level of contamination is high, you may have to add more amount of chlorine. And another reason is, the chlorine dosage must be increased during rainy season and also during epidemics. So if there is any news of any waterborne diseases or any epidemic diseases in the area, then also you can increase the dosage of the chlorine. Now next is, there are other forms of chlorine which can be used as a disinfectant. So what other different types of chlorine? You have now generally you have studied what it means by chlorination. Then you now you have to see in what different forms you can add chlorine to the water. Now first one, as free chlorine. So what are the different types of free chlorine which you can use in the water disinfection? So you can either use it in a liquid chlorine form or in a gas chlorine. That is two types of free chlorine which you can use as a disinfectant. And in combined chlorine form, you can use hypochlorites or bleaching powder. So bleaching powder, you have heard about it. And then in the form of chloramines, that is a mixture of ammonia and chlorine that you have seen. And then you can also use chlorine dioxide. So these are the different forms of chlorine which you can use for water disinfection. Now let's see the first one, liquid chlorine or gas chlorine. So the molecular chlorine can be carried and applied to the water to be treated either in a liquid form or in a gaseous form. Now liquid form of chlorine is more exclusively used. Now chlorine in its gaseous form is a greenish yellow colored gas, 2.5 times heavier than air, slightly soluble in water, and the gaseous form of chlorine gets converted into liquid form when subjected to a pressure of about 7 kg per centimeter square. So if you apply that much pressure, it gets converted into liquid. Chlorine gas does not catch fire, or it neither burns nor it explodes, and can therefore be safely stored in steel cylinders, either in a gaseous form or in a liquid form. Right? Now this gas chlorine usually causes irritation to the lungs and to the membranes of the eyes and throat. So chlorine content about, you can see here, chlorine content about 10 mg per liter or 10 ppm in the air can be easily noticed, and you can feel it. There is something wrong with the air. Some chemical is there in the air, so you can easily feel it. And then 20 mg per liter causes inconvenience, and 1000 mg per liter causes death. Therefore, the chlorine has to be stored properly and carefully, and it should be handled carefully so that there is no unnecessary leakage, because if it leaks into the air, these are the problems at different concentrations. So you should see that it does not leak. Now chlorine is applied to the water to be treated through an instrument called as chlorinator. So these chlorinators you will always find in the water treatment units, so that you can use it. Now what is the advantage of using free chlorine as a disinfectant is, it can be easily stored for a long time without any risk of getting deteriorated. So the quality does not get affected. Then it is cheap and easily available, occupies less space for storage, can be easily and cheaply transported. Chlorine dosage that to be added can be easily measured, and therefore chances of overdosing or underdosing is minimum. So you can easily measure how much amount of chlorine you want to add. You can exactly add it. So there is no chance of any overdosing or underdosing. So this is a very good thing about chlorine, right? So initial cost of installation of the chlorination plant is also quite low. It is a very powerful disinfectant and may remain in the water as a residue for a long time. So this is the most important character of chlorine. It is a powerful disinfectant, and it will remain in the water as a residue for a good enough time. So it remains as a residue for a long time. So therefore, even if water gets recontaminated again afterwards, the chlorine will continue its disinfecting action. It can be uniformly applied to the water, does not require any skilled supervision, and no sludge is formed because it is in a liquid form and a gaseous form. No sludge is formed in its application, as in case of the other types of chlorine products like hypochlorites or chloramines. So no sludge is produced, so it is a very clean process. So these other next forms of chlorine we'll take in the next video.